chapter 5 is about discrete probability distributions. Okay, first of all, we have to define what is discrete and what is continuous. Okay, we have a random variable, and that random variable can take any value in a particular set of interval. If this random variable can take particular values, this is a discrete random variable. However, if the random variable can take any value in a particular interval, then this is a continuous random variable. For example, the number of children a family may have. It can be 0 or 1 or 2 or 3 or 4 and so on. This is a discrete random variable. And in a continuous random variable, it may be weight, how much weight you may have. It may be any point in a particular range. Now, random variable is a numeric description of the outcomes of an experiment. And in order to have this function, we have f of x. In a discrete random variable, we have f of x and we have x, and over here we have the values, and f of x gives probabilities. Okay? And the same thing happening here. F of x, 0 is less or equal to any type of f of x less than 1, and if I sum all the f of x, it's going to be equal to 1. And in discrete probability distribution, the expected value of the function is what is called the mean, or mu, and that's equal to the sum of x times f of x. And the variance, that is called the sigma squared, is equal to the summation of each one of the x minus mu squared times f of x. Let's do an example, and I'm going to do an example of just a couple of elements to know how to calculate the expected value and the variance. Let's say that I have f of x, okay, and I have x, and I have only 1 and 2 values. For this one is 0.3, for this one is 0.7. Okay, so f of 1 is equal to 0.3 and f of 2 is equal to 0.7. Okay, if I have this table, I have f of x, I have x, 1 and 2, f of x is 0.3 and 0.7. Now, let's calculate the mean. Mean says that is the summation of x times f of x. This is x times f of x, 0.3 and 1.4. So I sum it and it's 1.7. And this is mu. Mu is equal to 1.7. What is the variance? This is x times f of x. I have to have this x minus mu. So I need x minus mu because that's what the formula is asking me. Okay, x times mu, x minus mu. This is x, this is mu. This is 1 minus 1.7 is negative 0.7. 2 minus 1.7 is positive 0.3. Now I need to square it. This board. Negative Why square it? Because I need it positive. 0.7 negative squared is 0.49. 0.3 squared is 0.09. Now I need to multiply by f of x. Okay, so this column times f of x. So it's 0.49 times 0.3 is equal to 0.147. This is x minus mu squared times f of x. 0.147. And this one times f of x is 0.7. 0.09 times 0.7, that is f of x, is 0.063. And if I add these two is 0.21. So 0.21 is my variance. What is the standard deviation? The square root. So the mean in this particular case, when I have only two values, when x is equal 1 and 2 and f of x is equal to 0.3 and 0.7, and it's a good distribution because the probabilities are less than 1 and greater than 0, and the summation is 1. So in this case, the expected value of this particular function is 1.7. The variance is 0.21, and the standard deviation is equal to 0.46. Okay, now we have two particular important probability distributions that are discrete probability distributions. And those distributions are the binomial distribution and the Poisson distribution. Okay, let's cover the binomial distribution. Okay, it is called binomial distribution because we have two possible outcomes. We have a multi-step experiment. Multi-step. Okay? We have independent. Each one of these steps is independent from the previous. And in each step we have two possible outcomes. These outcomes are either success or failure. Okay? Or you may call it whatever you want to call it. You may call it good and bad. You may call it male, female. You may call it whatever you want to call it. But there are only two possible outcomes in each one of the independent steps. The probability for success in each one of the steps is P, and the probability of failure, of course, has to be equal to 1 minus P. Why? Because there is only two possible outcomes in each one of the steps. And in the binomial distribution, we are interested in the number of successes in n trials. That's what we are interested in. That's what the distribution is all about. So the number of successes is discrete. That is why this is a discrete random variable. Now, f of x is the value of the function. This is the probabilities. It is nx. What is nx? Remember, nx is like the combination that we used to say. This is not this is not n over x, this is nx, or combination, times p to the power of x, that is the number of successes that we are dealing with, times 1 minus p of, to the power of what? N minus x. Okay? That's it. The expected value of this function, of this binomial function, is equal to np, and the variance is equal to np times 1 minus p. Let's do one problem of this. Let's do problem 26. In your book. 26 says, consider a binomial experiment with n is equal to 10 and p equal to 0.10. N is equal to 10 and p is equal to 0.10. So we have n steps, 10 steps, okay? And in each one of these steps, the probability of success is equal to 0.1, so the probability of failure is equal to 0.9. Whatever it is, I don't care what it is, success and failure, but they said that the probability of success is 0.1. And they want us to compute f of 0. Okay, go to the formula. This is 10, 0 times p, 0.10 to the power of what I'm looking for, 0, times 1 minus p, 0.9 to the power of n minus x to the power of 10.